You're at home one day when a package arrives. Inside is an instruction booklet and a plastic tube. Do not eat, drink, smoke, chew gum, brush your teeth, or use mouthwash for at least 30 minutes prior to providing your sample. The package is from one of those genetic testing services. The process is a little icky. They ask you to provide about 2 teaspoons of saliva, which you dutifully do. Then you seal the bottle back up and mail it back to the company's lab. There, they take the sample and extract the DNA from the cells in the saliva. Depending on which company you're using, they'll be looking for different genetic indicators. 6 to 8 weeks later, you log onto the company's website, and there are your results. Like most people, you're excited to see the results, dreaming of long-lost relatives maybe. But as you're scrolling through your profile, you suddenly freeze. A phrase catches your eye. Maybe it's breast cancer or Parkinson's disease. Whatever it is, you swallow hard. Someone in your family died of that, someone you were close to. You hesitate, unsure whether to continue reading. Now, you know the science here. People with certain versions of certain genes have a higher risk of developing this disease. Risks aren't certainties, though. Some people with high risk factors never develop the disease. But at that moment, that's not much comfort. You keep thinking about your grandmother, your uncle, your cousin, how much they suffered at the end. Perhaps they didn't recognize you or were confined to a hospital bed for months. It was awful. And now, the genetic testing company is asking you, do you want to know your risk? Should you face it head on, knowing there's no cure? Or should you turn away and live your life without that burden hanging over you? In the end, you decide it's better to know the risk. You've come this far after all. You take a breath and click on the link. American Innovations is pleased to have ZipRecruiter as its presenting sponsor. ZipRecruiter strives to lead the way in innovating talent recruitment to businesses of all sizes. Businesses need great people and a better way to find them, something better than just posting your job online and praying the right people see it. ZipRecruiter knew there was a smarter way, so they built a platform that finds the right job candidates for you. Their innovations have revolutionized how you find your next hire. We're back this week with Dave Tuttle, the Vice President of Product Strategy for ZipRecruiter. With Dave, the product team is constantly working to improve their technology to match employers with the best possible candidates. Stay tuned at the end of this episode to get to know Dave and ZipRecruiter's commitment to innovation. And now, our listeners can try ZipRecruiter for free. That's right, free. Just go to ZipRecruiter.com/AI. That's ZipRecruiter.com/AI. From Wondery, this is American Innovations. I'm Stephen Johnson. And a quick note, this episode contains some strong language. We've spent most of this series on DNA exploring breakthroughs and historic discoveries. Over the past 50 years, our understanding of the building blocks of life has grown leaps and bounds. We now know what those building blocks look like. And at the end of the last episode, we had a full printout of the entire human genome. It took supercomputers working overtime to produce a single genomic map. The first human genome completed in 2001 was actually a composite of a person, made up of DNA from several different men and women. It was supposed to represent an average human being. Now I can spit in a cup and drop it in the mail. You or I can have our own personal genome mapped for less than $100. But there are so many questions about how we ought to use the power of knowing what were previously unknown aspects of ourselves. It's divided people from the first moment it became reality. And this is the tension we'll be looking at in our final 2 episodes of this series on the dynamo of DNA. This is episode 5, Testing Times. Knowing the stuff we're made of has exonerated the innocent and convicted the guilty. It's opened new horizons in medicine and biology. It's also raised some unnerving questions. People come to different conclusions on those tough questions, even among the world-class scientists who first cracked the code. As the cost of sequencing kept dropping through the early 2000s, a second race emerged among the geneticists, a race to sequence the first full genome of an individual. And perhaps inevitably, Craig Venter and James Watson, two giants in the race to sequence the human genome in the first place, once again found themselves pitted against each other. A crew led by Venter began racing to sequence his DNA, and another group began doing Watson's. The race ended in another tie. Both Venter and Watson's genomes were made public in mid-2007. But when it came time to actually make that information public, the two men took slightly different approaches. It's early 2007. Watson's genome is about to be made public. James Watson meets with the scientists working on it in Texas. "We have a little gift for you, James." He hands a box to their honored guest. "I know I said we'd give you a DVD with your genome, but there was too much data. We got a hard drive instead. Not as elegant, but still it's pretty amazing to hold all that in your hand." "Well, my cells all hold a complete copy, and they're a hell of a lot smaller than this." "That's true. Well, then I guess there's just one more thing to discuss. Did you talk to your children about how much of this data to release?" "No." Why not?" "Because they might have said no." "But it's not just your genetic information. What about your son?" "What about him? It's no secret he's a schizophrenic. And this is bigger than my son alone. I'm very conscious of genetic losers. Other people want to deny their existence." Watson isn't referring just to his son. He's mindful of how some people are genetically predisposed to certain disorders, and he doesn't believe in hiding it. "Losers? I don't think we should quite put it that way, Mr. Watson." "I do. No need to sugarcoat it. My son never wanted to go to work or school because he couldn't fit in. Maybe genomics can help explain that. Publishing genetic information is a first step towards helping people with disorders like his. And it's better to understand people's limitations. Then we'll treat people better." "So you want it all released?" "No." The other scientists are surprised. "I'm blocking one gene of mine, APOE. Your Alzheimer's status? Every time I lose my car keys, I don't want to think, 'Oh God, is this it?' We're blocking that gene. End of discussion." And Watson did. He refused to release that one gene. Watson is still alive. He worked at Cold Spring Harbor Laboratory until 2007, when he came under pressure to step down following racist remarks that he made about black people being less intelligent than white people. Watson remains a controversial figure among scientists. In May of 2018, a few prominent geneticists came under heavy fire online for toasting Watson at a conference to celebrate his 90th birthday. Watson's history of sexist and racist remarks was brought up again. One scientist involved quickly apologized, saying that he himself had been the personal target of some of Watson's anti-Semitic remarks. While James Watson decided not to release all his genetic information, Craig Venter took a very different approach. "Good morning, everyone." Good morning, Craig. "We're adding an appendix to the paper with my genome." "Okay, what will be in it?" "It's a table. I've got a copy here. I've listed the variants of 24 genes of mine, then pointed out the increased risk I have for certain disorders: alcoholism, substance abuse, heart disease, Alzheimer's, antisocial behavior. But why? You don't have any of those problems." "Well, except antisocial behavior. You got me there. But that's the whole point. I have the risky genes, but none of those traits. We have to get over this irrational fear people have of even seeing their genetic code." "Okay, it's your genome. We'll add the appendix." "There's one more thing. I'm going to release all my medical records along with the genome." "Your doctor's records? Why?" "Because if people have that information, it's far more useful than just the genome alone." but you're completely exposing yourself. We've heard Jim Watson's not even releasing his APOE status. I know what Watson's doing, and I don't care. Let me ask you this. I got half my genes from my mother and half from my father. Well, my father was a smoker who died of a heart attack at 59. My mother's 84 and still plays golf and sails with me. Who am I going to take after? I have no idea. Exactly. No one does. But to answer that, we need both things, the genes and the medical records. There's going to be a different answer in each one of us. I don't think we have anything to fear, and we have a lot to gain. Venter, too, is still active. In 2013, he started Human Longevity to build a huge database of genotypes in order to better understand and combat diseases. In its words, the company aims to give everyone data-driven health intelligence. With Human Longevity, Venter hopes that humans will live longer by detecting diseases earlier. Like other scientists and technologists, Venter believes we can reverse aging and live much longer than we do today. As Venter himself suggested, knowledge is power. Who controls that genetic information and how it's used can have profound consequences. Data being collected today can be put to entirely different purposes tomorrow, some heroic and some troubling. The earliest foot coverings that could be considered socks were, the best we can tell, some form of animal skin pulled over the foot and tied off at an angle. The Greeks and Romans are known to have worn socks made from matted animal hairs. When it comes to keeping our feet safe and dry, we've historically done the best with what we've had to varying degrees of success. But lucky for me and lucky for you, over the last few years, there have been some incredible innovations in the sock department. Bombas socks, that's Bombas, B-O-M-B-A-S, are the result of 2 whole years of research and development that resulted in a significantly more comfortable, quality-made, and better-fitting sock than anything else on the market. With their stay-up technology, honeycomb arch support, and seamless toe, they really are the best socks I've ever owned. I just got a few pairs, and it's hard for me to put in words just how comfortable they are. They seriously have to be worn to be believed. And because socks are the #1 requested item in homeless shelters across the U.S., for every pair of socks that they sell, Bombas donates a pair to someone in need. You can save 20% off your first purchase by visiting bombas.com/innovations. That's BOMBAS.com/innovations. And enter the offer code INNOVATIONS at checkout. Let's go back to that test tube of saliva you sent off to the genetic testing company. When it gets to the testing lab, the company begins extracting your DNA from the cells inside the saliva. It's actually a pretty easy process, similar to what you could do at home by mushing up the cells and adding soap and salt and rubbing alcohol to isolate the DNA. In fact, it's not too different from what Friedrich Miescher did in the 1860s. The company next amplifies the DNA, basically making more copies of the DNA so there's enough to process. Then they use high-tech sequencers and computers to read the specific strings of A's, C's, G's, and T's in your genes, a bit like the Human Genome Project. But unlike the Human Genome Project, these companies only look at a tiny percentage of your total genome, usually less than 1%. If it's a company that looks at your ancestry, they examine specific genes to see if they match the versions of genes that people have in different regions around the world. If they're checking for health conditions, they're looking at genes associated with increased risk for those conditions. But those genes, they make up a tiny fraction of all the billions of letters of code in our DNA. See, genes, the stretches of code that make the proteins that run our bodies, account for just 2% of all human DNA. Scientists call the other 98% non-coding DNA. So what does that other 98% do? Well, interestingly, a good chunk of our so-called human DNA isn't human at all. Some of it comes from other species, like Neanderthals. Neanderthals were a close cousin of human beings who lived in Europe and Western Asia and died out roughly 40,000 years ago. In popular culture, they're portrayed as brutes. Calling someone a Neanderthal is fighting words. But humans and Neanderthals coexisted on Earth. And recent discoveries show that Neanderthals were more like us than we realized. They had art and culture. They buried their dead, and perhaps had rudimentary language. Most startling of all, Homo sapiens and Neanderthals had sex with each other. Hence, some of their DNA is mixed up with ours. Depending on your ancestry, Neanderthal DNA might make up around 2% of your genome. That still leaves most of the genome unaccounted for. So even with all we now know, there's still about 40% of all the genetic code that's a mystery to us. Scientists don't know what it does. Some of it probably helps turn genes on and off, or regulates them in other ways. But some portions look useless, long, repetitive stretches of the same few letters, like Mother Nature held her fingers down on the keyboard for a while. Even if these long chains of the same letters don't seem to do much biologically speaking, they've proven very useful outside of biology. For one thing, they're the keys that have unlocked thousands of criminal cases. It's 2 a.m. on a sweltering August night in 1984. And in Cambridge, Maryland, police are moving in to arrest Kirk Bloodsworth. A few cops sprint through Bloodsworth's yard and pound on the door. "Open up!" Bloodsworth is a 22-year-old crab fisherman and former Marine. He opens the door sleepily and is blinded by a flashlight. Before he knows what's going on, one of the cops cuffs him and growls, "You're under arrest for first-degree murder, you son of a bitch." 2 weeks earlier, a 9-year-old girl had been found raped and murdered in the woods. After a statewide manhunt, the police have finally tracked Bloodsworth down. He's taken into custody and eventually brought to court. The prosecution's case is shaky from the start. It's based largely on the testimony of eyewitnesses, 2 of whom are children. They were fishing nearby and claimed they saw someone enter the woods with the victim. They described the man they saw as a scrawny 6'5" man with curly blonde hair. Bloodsworth stands a half-foot shorter and is a stocky redhead. Despite these inconsistencies, Bloodsworth is convicted and sentenced to death in March 1985. He instantly becomes the most notorious inmate in Maryland. Other prisoners fling bottles of urine into his cell. One attacks him in the bathroom with a sock full of D batteries, smashing his skull. But even though it only brings him more trouble, Bloodsworth maintains his innocence. He even signs his letters Kirk Noble Bloodsworth, AIM. It stands for An Innocent Man. And the fact is, he's actually telling the truth. Bloodsworth is on death row for a crime he didn't commit. Bloodsworth begins working as the prison librarian, spending most of his time alone, reading. And that is how he comes across a true crime thriller about the police hunting down a rapist using something called DNA fingerprinting. Back in 1984, the very same year Kirk Bloodsworth had been arrested, a scientist at the University of Leicester in England had what he would later call a eureka moment. Alec Jeffreys was looking at X-rays taken of DNA, part of an experiment looking at inherited diseases. He'd left some X-rays to develop over the weekend, and now he pulled them out of the developing tank. God, what a mess. The X-ray looks like a barcode, but as he looks closer, he notices something. Come and look at this. What is it? Well, we got one of these samples from one of the technicians in the lab. And over here are her mother and father's. Do you see what I'm seeing? The lines. Her DNA looks like a mix of her parents. Exactly. You can see that they're related just from the X-rays. This is incredible. I know. Just think of all the possible applications it could have. Paternity tests, archaeology, crime scenes. Jeffreys would soon put this idea to the test, leaving samples of his own blood around the laboratory to see if it could be used to identify him just from his DNA. It could. Our DNA, our genetic code, could now be used to identify the guilty, or maybe to set an innocent man free. It's Alec Jeffreys' discovery of genetic fingerprinting that Kirk Bloodsworth reads about in prison. In the book, British police were able to force a suspect to provide a DNA sample. They then compared it with the DNA taken from the crime scene. The DNA was a perfect match, and the man was convicted. It's a sensationalized account, but Bloodsworth keeps circling back to one point. If DNA can catch someone by putting them at a crime scene, then surely it can free someone too by proving they weren't there. Bloodsworth grows obsessed with DNA. He knows the police found semen in the victim's underwear, and he asks his lawyers to get it tested. No one has ever used DNA evidence to free someone from prison, and it seems risky. DNA fingerprinting is still experimental, and if the results are inconclusive, it might make Bloodsworth seem more guilty. His lawyer says no. But Bloodsworth doesn't let up. He insists day after day after day. The attorney finally gives in and puts up $10,000 of his own money for the test. Bloodsworth's team gets hold of the victim's underwear. They swab it for DNA. Given the sluggish pace of biotechnology then, they'll have to wait a full year for the results. But they have no other options. All they can do is drop the evidence in the mail and pray that their $10,000 gamble pays off. So how does this testing actually work? It all comes down to those repetitive sections of DNA. These repeating sections of code are kind of like stutters. All human beings have these stutters, and each one of us has a unique set of stutters, as unique as our fingerprints. We can therefore use them to tell one person's DNA from another's. Typically, forensic scientists take DNA from blood or semen at a crime scene and analyze the stutters. Then they compare those stutters to the stutters in each suspect's DNA. If they match in both cases, they've got their suspect. If not, they've got the wrong person. But back in the 1990s, this kind of testing was expensive and it took a long time. Bloodsworth had to wait a year for his results. Another year in prison. For 12 months, Bloodsworth waits. He delivers books and lifts weights. He's on friendly terms with a few of the other inmates, but mostly he sticks to himself. He still signs his letters A.I.M. Finally, in the spring of 1993, Bloodsworth's lawyer hears back from the lab.
Kirk?
Yes?
We got the results.
The DNA shows Bloodsworth is not the killer. His lawyer later said, "It was a wonderful phone call. It was the type of phone call a lawyer dreams of." Bloodsworth starts crying, but after the tears clear, he begins whooping and hollering for joy. He gets a new trial, and after 8 years, 11 months, and 19 days in prison, he walks out a free man. Bloodsworth was the first American sentenced to death to have his conviction overturned because of DNA evidence. To some people, he's a hero. Waiting for him at the prison gate is a limousine, a gift from a local radio station in Baltimore. "They had one of their DJs come there to take me around town," he later said. "They had a big cooler full of beer. It was something else." Still, not everyone thinks Bloodsworth is innocent. He once came back to his car to find someone had written "child murderer" into the dirt. But then, in 2003, Bloodsworth is at home with his new wife when he gets a phone call. "Hello?"
Hello, Mr. Bloodsworth?
The voice on the line drags him right back to the trial.
This is Ann Brobst. I was one of the prosecutors at your first trial.
"I know who you are."
Look, we need to meet. There's something I have to talk to you about.
"What is it?"
I can't tell you over the phone. Are you free tomorrow?
Bloodsworth names a Burger King near his house and hangs up. He's suddenly on edge. What did Brobst want? Were they trying to railroad him again? That night he can't sleep, and he spends hours pacing and worrying. The next day, he pulls into the Burger King parking lot with his wife and attorney for support. He sees Brobst, and all the fear and terror of the trial floods back. But he says hello, and they walk inside together. Brobst buys him a soft drink, and they sit down. So, what did you want to talk about? Brobst looks at him. We got a hit on a guy. For a split second, Bloodsworth isn't sure what she means. Then he understands. A DNA hit. The same DNA evidence that exonerated him has now nailed someone else. In the years after Bloodsworth's case, in fact, partly because of his case, DNA fingerprinting has become a powerful tool in criminal investigation. The state of Maryland had begun collecting DNA from prisoners a few years earlier and running it through a database, searching for hits on cold cases. And in 2003, they finally got one. Bloodsworth starts to cry. He can't help it. After 2 decades of hell, his name will finally be cleared. And despite all his lingering resentment, he reaches across the table and hugs Brobst. After collecting himself, Bloodsworth asks her, almost as an afterthought, who the real murderer is. She gives him a name, Kim Ruffner. Bloodsworth's face flips from teary relief to shock. My God, I know him. It turns out that Ruffner was one of the prisoners he'd been friendly with on the inside. Ruffner had a history of rape convictions. He'd been released from jail a few weeks before the murder, and a few weeks afterwards, he'd raped another woman and tried to kill her with scissors. After being caught, tried, and convicted for that rape, he ended up in the same prison as Bloodsworth. Just like everyone there, Ruffner knew about Bloodsworth's case and knew about his efforts to prove himself innocent. But all the times they interacted, in the weight room, in the prison library, he never betrayed the truth about the murder. Bloodsworth would later recall that even though Ruffner was one of the few people who treated him decently, he always acted a little peculiar in his presence. Now he understood why. Despite Ruffner's history, no one ever thought to connect him to the murder. But DNA did. And in finally pinning the crime on someone else, it cleared Kirk Bloodworth's name a second time. This time for good. American Innovations is brought to you in part by Wix.com. Showcase your bright ideas and innovations with Wix. They've developed artificial design intelligence that creates a stunning website for you, whatever you've dreamed up. Wix can help you share it with the world. And now you can create your website right from your phone. That means you can open your own online store, portfolio, blog, wherever you are, even while listening to this podcast. All you have to do is go to Wix.com, decide what you need a website for, pick your style, add your images, and just like that, your website is ready. You'll look amazing on every device, desktop and mobile, and it takes less than 5 minutes. I can't think of a more powerful way to spend such a short amount of time. Great innovations can change the world, but first, the world has to know about you. So what are you waiting for? It's time to get started. Go to Wix.com, that's Wix.com, and create your very own beautiful professional website today. It's April 25th, 2018. The District Attorney of Sacramento County steps up to the microphone to make a major announcement.
We all knew, as part of this team, that we were looking for a needle in a haystack. But we also all knew that the needle was there. For anyone that lived here in this community, here in Sacramento, the memories are very vivid. Everyone has a story. There were upwards of 50 rapes, 12 murders. Crimes that spanned 10 years across at least 10 different counties, northern, central, and southern California.
Schubert was describing the arrest of a suspect in a case that had become known as the East Area Rapist or the Golden State Killer. Starting in 1976, the Golden State Killer raped 50 women, killed 12 people, and committed 120 burglaries. His spree lasted 10 full years. And at the end of it, police had 0 leads. Facial sketches caught no one, and psychological profiles came up empty. Even DNA couldn't help, at least not at first. Investigators had the killer's DNA from blood and semen samples left at crime scenes, and California had a database of suspected criminals' DNA. But there were no matches. Until police tried a new and unusual tactic: online genealogies. At the time this episode was recorded, the police haven't yet revealed all the details of their investigation. But experts say they probably did something like this. Some people who get their genomes sequenced want the nitty-gritty details of their DNA. So they download their raw genetic data from a testing company and upload it to third-party sites. This allows them to search their DNA more thoroughly. These third-party sites don't always have the privacy restrictions that mainstream companies do, meaning outside parties can access the data too. Investigators in Sacramento took the Golden State Killer's DNA and plugged it into some of these sites. They didn't find a direct match, but what they did find were some near matches from people who they realized could be the suspect's relatives. They determined the identity of the relatives on the site and built a family tree from public records. From there, they looked for people of the right age who lived in Sacramento in the 1970s and the 1980s. They eventually zeroed in on a former police officer named Joseph James DeAngelo. The police began to surveil DeAngelo, following him for 6 days. Their goal was to secretly collect a DNA sample. No one knows how they succeeded, a discarded water bottle or cigarette perhaps. Or maybe they dug through his trash for stray hairs or half-eaten food, all of which can leave traces of DNA. But after acquiring something and testing it for DNA, they compared it to the DNA from the crime scenes. It matched. Investigators announced DeAngelo's arrest this past April 25th, which just so happens to be National DNA Day. DeAngelo, now 72, is currently awaiting trial. The outcome may be satisfying, but the way in which the alleged killer was caught raises alarms about genetic privacy. The police probably took DeAngelo's DNA without a warrant, and he himself never put his DNA online. Only his relatives did. It raises some tricky legal and ethical questions. Imagine if your mother or sibling or even a second cousin once removed, someone you've never met, posted their DNA on some uncontrolled forum. That information says a lot about you, too. It might not tie you to a crime, but it could reveal information about your health, your heritage, or your susceptibility to certain diseases that you might not want public. In June of 2007, 2 senators introduced a new bill into Congress. The bill aims to speed up genetic research by standardizing technology and terminology and that kind of thing. The long-term aim is personalized medicine, medicine that is tailored specifically to you based on your genetic makeup. One of the senators is Richard Burr, a Republican from North Carolina. The other is a young senator from Illinois, Barack Obama. He's a supporter of this kind of research, but Obama tells an aide, "I don't want the bill to go anywhere until GINA passes." GINA is the Genetic Information Non-Discrimination Act, a bill that in some ways is designed to prevent a kind of discrimination that hasn't even happened yet: genetic discrimination. Its supporters want to prevent insurance companies or employers or anyone from denying jobs or health coverage to someone because of their genetic code. GINA does eventually pass, with bipartisan support. President George W. Bush signs it into law, and it's still on the books. Still, those ethical issues could pale in comparison to what comes next. Because in the past decade, a new technology has come along that, if anything, is even more revolutionary than the discovery of DNA or the human genome. Now we have the option not only to read our genetic code, but also to rewrite it. And that's in our next episode. All of that data is stored in your genes, and scientists don't even know what to do with all of it. They don't even know what most of it means. Maybe science will catch up someday and we'll finally know. But according to Dave Tuttle, Vice President of Product Strategy at ZipRecruiter, human behavior is a little easier to predict.
So when you go to Netflix, it tells you what you should be watching, and oftentimes it's right. And it's doing that based on your user behavior, based on other people's user behavior. They're processing millions of points of information to tell you that you need to watch the newest movie or Netflix show.
Netflix, Spotify, whatever you use, all do similar things when they suggest new stuff for you. They're predicting you'll like their recommendations based on your past choices. Now take that same concept and apply that to job seeking and hiring.
You know, you have so many options. We're narrowing it down for you. You may not know how to self-identify with your skill set. You may not even know what's out there that meets your goals and aspirations as a job seeker. We're going to help you with that process, and we're going to do it in a way that serves you as a job seeker. It also serves large companies well because you're such a great fit, and we're helping to make that connection between the two of you.
Sometimes all it takes to fall in love with a new show is a recommendation from someone you trust. Businesses of all sizes trust ZipRecruiter to recommend the best candidates for their job postings. ZipRecruiter matches employers with great quality talent. In fact, 80% of employers who post on ZipRecruiter get a quality candidate through the site within the first day.
And you can try it right now for free. Just go to ZipRecruiter.com/AI. That's ZipRecruiter.com/AI. One more time, ZipRecruiter.com/AI. ZipRecruiter, the smartest way to hire. I hope you enjoyed this episode of American Innovations. If you did, please do give us a 5-star review and tell your friends to subscribe. We're available on Spotify, NPR One, Apple Podcasts, and every major listening app, as well as at Wondery.com. Love the info you heard? The author of this series, Sam Keen, has several wonderful books about DNA and neuroscience and more. His book on DNA is called The Violinist's Thumb, and it's available wherever books or ebooks are sold. You can learn more about his books on his website, samkeen.com, where you can follow the links in the show notes. And a quick note about these historical recreations you've been hearing. In most cases, we can't know exactly what was said. Those scenes are dramatizations, but they're based on real historical research. If you're listening on a smartphone, tap or swipe over the cover art of this podcast. You'll find the episode notes, including some details you might have missed. You'll also find some offers from our sponsors, like Bombas. Please support our show by supporting them. And thank you. American Innovations is hosted by me, Stephen Johnson. For more information about my books, including the scientific detective story, The Ghost Map, you can visit my website at stephenberlinjohnson.com. Sound design on this episode is by Bay Area Sound. This episode is written by Sam Keen. The producer is George Lavender, executive produced by Marshall Louis for Wondery.